Welcome to video number 47 in the Using iTrain tutorial series. My name is Bob. This is exercise 1, part 3, in which we look at the running of both trains simultaneously. Welcome back. So, we have managed to get both trains running separately using automatic routing without a route. Now we want to ensure that both trains can run together at the same time. Just to quickly recap what we have done so far. We used the template layout that was provided. We set the block directions so that each of the blocks were now bidirectional except for B1, so that the shuttle can run around the layout in either direction. We left B1 as unidirectional because only the intercity train would be using that block, and the intercity train only travels in a clockwise direction around the layout, which is in the direction next. In block B2, we unticked the direction change forbidden parameter to allow a change of direction to be permitted in B2. Remember, we want the shuttle to change direction after a wait in B2. The blocks in station 1, if we go to the station properties here and click on the blocks tab, the blocks here are set at their default values, but we changed the direction of B2 from next to both using the drop-down menu here, and that allows trains to enter B2 from both directions when running automatic routing without a route. In the Train Types tab, we made entries for the intercity train and for the shuttle train. These two train types are then permitted to use station 1 when running automatic routing without a route. We removed the default entry called all train types so that no other train types are able to use station 1 when running automatic routing without a route. Those other train types will not even be able to pass through the station. The intercity was set up to stop and wait 35% of the times it enters the station, and to wait for between 5 and 10 seconds. The other 65% of the times it will pass through the station without stopping. And for the shuttle train, we set it up so that it will always stop when it arrives in the station, and it will wait for between 10 to 15 seconds. And by ticking the direction box, we also set it up so that it will automatically change direction after a wait 65% of the times that a wait occurs. In station 2, we set up the blocks at their default values, and here we also changed the direction from next to both, so that the shuttle again is able to use this block when entering it in either direction. If we had left it at next, the shuttle would not have been able to use the station here when travelling in an anti-clockwise direction, so in direction previous. If you'd left it at next, you may have found that when you tried to start the train here and travel in the clockwise direction, in direction next, the train would successfully complete a loop, but when you tried to run it in the other direction, it would not leave this station. The reason being is that it was not able to enter this block in the direction previous. So that's why this needed to be set to both. And in the train types tab, we made similar entries for the intercity and the shuttle train, except that in station 2 we did not tick the direction change for the shuttle, so the change of direction would not occur in station 2 and would only occur in station 1. So let's see how things perform when we try to run both the trains together. We will drag the intercity into block B1 and we'll drag the shuttle train into block B2. Then we can either start each train individually by clicking on their start buttons in the throttles here, or we can long left click on the station and select start from here, and that will start all the trains that are in the station. So we'll click on start and you see that DB Pol has reserved the route out onto the layout. If I long left click on the station again and select stop, it will stop all trains that are currently in station 1. So I'll do that again, and then I'll restart all trains again, and you notice that DB Pol is the first train again to start out of the block. If I was to just stop DB Pol, which is this one down here, you will notice that DB Pol will stop, but then DBIC will start its route. Let me show you. I'm going to just stop the individual train called DB Pol by clicking the stop here, and you can see that DBIC has immediately started because it was waiting in the queue to start due to us starting both trains using this start function here. So if you use the start function to start all trains and you then want to stop all the trains at the same time, you must use the stop function from this menu and not just stop the individual trains, because any that are still in the queue would then still try to run around the layout. So I'm going to choose stop from up here again. The reason that db poll always starts first when we use this function is due to the priority that is set in the train types. If we go to train types and click on the intercity, which is db poll, you see that it has a priority of 1 in the options tab here, and the shuttle train has a priority of 2, so it's a lower priority. If we were to change that around and make the shuttle train priority 1 and the intercity priority 2, then click apply. Then when we long left click and start the trains, we will see that it is DBIC, the shuttle train, that now starts first. So let's let both trains operate and see what happens. So we'll double click on the feedbacks to allow this to continue round. You note that db poll has not left the station yet. iTrain knows that DBIC will be coming around this way, so has prevented it being released, db poll being released. Then we'll progress DBIC around into here. We are expecting at some stage to be a change of direction to occur when the wait is finished. The wait is going on at the moment. You see that db poll has now been released around the track. Let's have a look and see what happens. You see the direction arrow then changed, so a direction change has taken place for DBIC, which is what we programmed. We'll let db poll continue round. This is just going to go round in the clockwise direction each time. DBIC has now been released and is coming out of the station, so we can let that go round and continue db poll into station 1, where it will wait 35% of the times. The wait for the shuttle train DBIC is coming down. db poll has now been released, so we can move that out. We'll progress DBIC around into B2. db poll we can move into D4. Progress db poll around into here. Let's see what happens to the wait when the wait finishes here. No change of direction occurred that time, which is fine because we have only set it to change direction 65% of the times, I believe. Let's progress db poll around. db poll this time is going to go straight through the station, but it is allowed DBIC to be released, which is also fine. DBIC is now coming out of the station, and we'll move into wait at B4. We'll progress db poll into there. We'll progress DBIC. db poll has been released, but can go no further yet because DBIC is waiting here. And when that wait has finished, the speed has increased, so we're safe to double click and allow DBIC to move into B2. db poll we can progress around. It's moving into the station here. And let's see, yeah, a change of direction occurred there, which is great. So now DBIC is going to start coming back this way, and we can progress DBIC and let that go into station 2. Let the wait finish. DB pole has been held there because iTrain is intelligent enough to know that this train is going to be coming around this way. Wait for the speed to increase. We can also see the speed increase by looking at the blue bar. Then we are safe to double click the feedbacks to manually progress the train. DB pole has been released. Now we can watch what happens with the direction. The direction has changed. It's moved to the other direction there. DBIC has been released. Let's just do this a few more times. DB pole has been released. Let's cancel the wait. We can cancel that wait to make it a bit quicker. Then progress that into here. DB pole is moving into here. Now I'm going to deliberately leave this reserved here. See if a change of direction occurs. No change of direction occurs, so that is one of the 35% of the times where it doesn't change direction, which is fine too. Let's progress these all around. DBIC down to here. DB pole can come out of there. We can cancel that wait to move it on a little quicker. Now we can't, or we shouldn't cancel the wait when the train enters here, because cancelling the wait will cancel the change of direction. The change of direction only occurs when a wait has been completed. If we cancel it, it will not occur. Now you notice this has changed direction to come back this way. But we've got DB pole coming in this direction. Now watch what happens to the change of direction here. You see it changed back to go clockwise, even though it had changed direction to go anti-clockwise. It was intelligent enough to see that it wouldn't be able to go round in an anti-clockwise direction on this occasion because DB pole was coming around. So iTrain decided, well, I can still progress the train if I go round in a clockwise direction. So it was intelligent enough to spot that and allow the train to keep moving. Now we can progress DB pole into the station here, and what we could do at this point is actually stop both trains by selecting the stop here, and now both trains have stopped in station 1. So hopefully you were able to see that without changing any of the settings, we were able to get both trains to operate together on the layout without any deadlocks occurring and without any trains crashing into each other. DB Pol, the intercity train, was always travelling in a clockwise direction and was randomly waiting approximately 35% of the time that it entered station 1 and station 2. DBIC was able to travel around the layout in both directions and was able to automatically change direction approximately 65% of the times that the wait was completed in station 1. We saw that occasionally when the wait had completed, we saw the arrow change direction to go the other way with the intent of going the other way, but because DB Pol, the intercity train, was on a route around this clockwise direction, iTrain was intelligent enough to see that DBIC would not be able to be released going anti-clockwise, and so iTrain decided to change the route direction back to the clockwise direction and allow DBIC to be released in that direction. And that is perfectly correct behaviour for the shuttle train when running automatic routing without a route, because iTrain is having to make the decisions about the path that the train will take, and in real time it is analysing what is happening on the layout and will sometimes make decisions to allow the train to run in another direction if the intended direction cannot be achieved due to a train already reserving that path. So that concludes this exercise. What you have seen was just my solution to the problem, which doesn't mean it is the best and only solution. As we are beginning to see, iTrain often offers many different solutions to problems. The best solution for you is the one that best meets the operational needs of your layout. And we all have different ways that we want our trains to run. So if you have a different solution, post it on the forum in the tutorial 44 post that you will find in the support and automatic control section of the English forum. I and many others will be interested to see different solutions. Okay, let's move on and do a little bit of revision on some subjects we have covered before, but which could be applied in this situation. Now, depending on the wait times that have been set for the shuttle train and for the intercity train, and depending on the structure of your layout, in other words, whether you've got turnouts that are in between blocks, etc., you may find that occasionally a deadlock does occur. For example, DB Pol might be trying to come round in this direction, the clockwise direction, and DBIC, the shuttle train, has already been released and is travelling around in this direction, and a deadlock occurs because they're both trying to enter B4 together. If you have deadlocks occurring on your particular layout, you can prevent those deadlocks occurring by making specific blocks critical. So if you left click on the block here, like B3 for example, and when the train is travelling in a clockwise direction, which is direction next, we go to the direction next tab and we can click this critical parameter here. That then means that this block will not be reserved if the block ahead can also not be reserved. And that would mean if the shuttle train was trying to go around in a clockwise direction, when it leaves the station here, it would reserve 2 blocks ahead. So it would reserve this block and this block here. Both of those blocks would turn orange. And if the intercity was trying to leave in a clockwise direction, it would not be able to reserve this block because this block is reserved by DBIC. Because this block is critical, it cannot be reserved unless the block ahead is also able to be reserved. With DBIC coming this way and reserving both of those blocks, that block and that block would not be able to be reserved by DB pole coming out in this direction, and so DB pole would stay where it is until both of these blocks are cleared, and that would prevent a deadlock. Let me see if I can simulate that. So we'll change the direction of DBIC, then long left click, start the trains. So DBIC is moving out this way. DB pole is not able to move out because it cannot reserve both of these blocks at the same time. We have made this block critical. If we allow this to move around, let it go into the wait. We can cancel the wait because we don't need to wait for it. Let DBIC progress into here. Once it is cleared here, which it just has, DB pole is now released. It is able to reserve both of these 2 blocks together. So it is allowed to progress through. We'll cancel the wait. Now you see DBIC has not been released out of here because this block is occupied. Remember, by making this block critical, a train coming out of here cannot reserve this block until the blocker ahead is also clear. So if we let DB pole go out of here, in this particular occasion DB pole is moving around in a circle, so we'll let that continue. That is correct operation as well. Let it go around into the station here, and now because DB pole has cleared B4, iTrain is then able to reserve both these blocks and allows DBIC to progress out onto the layout. So that is the effect of making a block critical. Let's long click and stop. But on our simple layout here, running in simulation, it is not necessary to make this block critical. All I'm trying to say to you is that on your particular layout, you may come across occasions when a deadlock occurs, and one way of preventing those deadlocks is to experiment with making blocks critical, which would prevent that deadlock occurring. Now, another way we could operate this layout is by using the threshold value for the station. If you remember back to that tutorial, if we select the station properties and go to the options tab, we have this threshold parameter here. And by ticking that and selecting the threshold of 1, pressing OK, that will now only allow one train at a time to enter and progress around the layout. So let's see how that performs. We'll long left click and select Start. DBIC is allowed out onto the route. You can see that DB pole is waiting. It's gone a solid yellow. So we'll progress DBIC out into the layout, and we'll be able to cancel the wait here, so we don't have to wait too long. Oops, there you go, cancel. Wait for the speed to increase and then let it come through. So you see DB poll was not released until DBIC entered the station. So now DB poll is allowed out onto the layout, and it's going to pass straight through the station. DBIC is left waiting. It's changed its direction. You see it's now going in an anti-clockwise direction, but it may not retain that. iTrain may decide that it will revert back to going clockwise again if it sees that DB pole is in the way traveling clockwise here. So let's see what happens. Right, so DB pole is now going to wait in the station. You see iTrain has now said, well, I can't go in this anti-clockwise direction for DBIC, therefore I'm going to allow it to continue round going in the clockwise direction. And if we progress that in there, and then we can progress DBIC. So using the threshold value reduces the amount of traffic that is actually out on the layout, but otherwise operates in a similar way to not using the threshold. Let's allow DBIC to come back into the station here, and then we'll do a long left click and stop. Now, what if for some reason you did not want iTrain to change direction back to clockwise if it was not able to allow the shuttle to go round in the anti-clockwise direction? What if you wanted iTrain to wait until DBIC can go in a anti-clockwise direction? Then we could do that using a train route, because with a train route we can define precisely what is happening in the route. And just to show you that, I've created a train route here called shuttle return. And if we go to the train routes editor, shuttle return, all it is doing is the train is starting in B2. It travels to B4 down here where it will wait in direction next. It's entering the block here in direction next. It then goes from B4 to B2, entering the block in direction next, the clockwise direction. In the next step, we ask it to go to B4, but entering B4 in the direction previous, so the anti-clockwise direction, where it will perform a wait. And then it's going to go from B4 to B2, entering B2 in the direction previous, which is again the anti-clockwise direction. And then the loop repeats again, where it goes from B2 around to B4 in direction next, and so keeps repeating that loop for as many times as we have got the repeat set to. For an infinite repeat, if you remember, we set the repeat value to 0. Oh, and don't forget, for it to be able to change direction, we need to have the proper selection in this change direction block here. So either dependent on train, or we could click allowed for it to occur with any train, or forbidden, but we would do it dependent on train, and click apply. Let me just remove the threshold that we set up in station 1, and then we can watch the operation with the train route now selected and see how that operates. So I'll long left click and click the start. So DBIC has been allowed out. It has the highest priority, remember. Double click, allow it to progress around the layout just as before. DB poll has been allowed out straight after. We can move that along. DBIC is going into station 1. It's completed its wait. DB poll is going into station 1 as well. You notice DBIC did not go in the clockwise direction, even though the DB poll was coming around in this direction. So it was held here until this block was free, and now it is coming round in the anti-clockwise direction. So you can see the difference in the behavior of the train when running the train route compared to automatic routing without a route. And then DBIC will come into the station here. Once it clears this block, DB poll will be released. DB poll is going to wait in B4. We will cancel the wait. You see the change of direction has occurred. DBIC is now coming back in the clockwise direction. DB poll is released. DBIC comes round. We'll just let that repeat the change of direction again. DBIC into here. We'll see that change of direction occur. Currently it is going clockwise. Right, DB pole is going straight through the station here, so DBIC will be held until DB pole waits in station 1. So it's continuing to go round in a loop, which is perfectly acceptable operation for what we have set DB pole to do using automatic routing without a route. Remember, it will only wait 35% of the times that it is going into station 1 and station 2. So it's chosen to wait this time in station 2. We'll cancel the wait to speed it up. Long click, cancel wait, and this time it will stop, and we will see DBIC being released then, and the change of direction occurred, and now DBIC is coming around in the other direction again. So you can see now that every time the wait or every time DBIC visits station 1, it changes direction regardless of what DB pole is doing. And so that is it. I hope that was useful to see how to set up the stations and influence the way that the trains operate when we're using automatic routing without a route, and to see how a train route can be used to provide more definition about the operation of the trains. Now, the way that we saw the shuttle behaving using the train route can also be achieved using automatic routing without a route by using something called actions. And that is the subject of the next tutorial. I know that actions is a topic that a lot of you have been waiting for. It will probably take me a couple of weeks or more to produce it, so please be patient. There is a lot of preparation work and experimentation that needs to be done to ensure that it is presented in an easily understandable way and which has context. So, hope to see you then. Thanks for watching. And if you like what you saw, please remember to hit the like button. Bye now.